Before diving into penetration testing techniques or setting up a secure delivery pipeline, every cybersecurity practitioner must understand what they are actually protecting against. The OWASP Top 10 is the most widely recognized reference in web application security. It is published by the Open Web Application Security Project, a nonprofit foundation dedicated to improving software security. This list is updated periodically. The most recent version dates from 2021, and it identifies the 10 most critical security risks facing web applications. It is not an exhaustive catalog of every possible vulnerability, but rather a prioritized guide based on real data from hundreds of organizations worldwide. Understanding the OWASP Top 10 is not just academic knowledge. It directly shapes how you approach a penetration test, how you write secure code, and how you configure your automated security checks in a continuous integration and continuous delivery pipeline. In the context of your career transition toward a DevSecOps and cybersecurity specialist role, this list is the backbone of your daily work. Let us now go through each of the 10 categories in detail. 1. Broken access control. Access control refers to the enforcement of restrictions on what authenticated users are allowed to do. Broken access control means these restrictions are either missing or incorrectly implemented, allowing users to act outside their intended permissions. Concrete example: imagine a web application where a regular user can access the admin panel simply by changing the URL from /user/profile to /admin/dashboard. No additional verification is performed server-side. This is a classic broken access control vulnerability. Another example: a user accesses their own invoice at /invoice?, it equals 1042. By changing the identifier to /invoice?, it equals 1043, they can view another user's invoice. This specific pattern is called an insecure direct object reference. This category ranked first in the 2021 list, up from 5th in 2017, reflecting how frequently it appears in real-world audits. 2. Cryptographic failures. Previously labeled as sensitive data exposure, this category was renamed in 2021 to focus on the root cause rather than the symptom. Cryptographic failures occur when data is not properly protected in transit or at rest, often due to weak or absent encryption. Concrete examples of cryptographic failures include a website that still allows connections over plain HTTP instead of HTTPS, exposing passwords and session tokens in clear text on the network. A database that stores user passwords as plain text or using an outdated hashing algorithm such as MD5, which can be cracked very quickly with modern hardware. An application that uses a weak encryption key or reuses the same initialization vector for every encryption operation, making it possible for an attacker to deduce the original data. From a DevSecOps perspective, automated static analysis tools can detect some of these issues, such as the use of deprecated cryptographic functions in source code. 3. Injection. Injection vulnerabilities occur when untrusted data is sent to an interpreter as part of a command or query. The interpreter cannot distinguish between legitimate instructions and attacker-controlled data, and executes both. The most well-known form is SQL injection. For example, an application builds a database query like this: select from users where username equals input. If the attacker inputs OR1 equals 1, the query becomes select from users where username equals OR1 equals 1, which returns all users in the database. Other forms of injection include command injection, where attacker input is passed directly to a system shell command; LEP injection, targeting directory services; XML injection and template injection in modern web frameworks. Injection was the #1 risk for many years before dropping to third place in 2021, mainly because modern frameworks and prepared statements have made it easier to avoid, though it remains extremely dangerous when present. 4. Insecure design. This category, new in the 2021 edition, addresses flaws that are baked into the architecture or design of an application before a single line of code is written. It is distinct from implementation bugs. It reflects a fundamental absence of security thinking during the design phase. Concrete example: an application that allows unlimited password reset attempts without any rate limiting or account lockout. An attacker can automate thousands of attempts to guess reset code sent by SMS. The problem is not a coding mistake, it is a design choice that failed to consider the threat. Another example: a financial application that has no separation between the role that creates a payment and the role that approves it, enabling fraud from within. Addressing insecure design requires threat modeling during the design phase, which is a practice you will encounter throughout this course. 5. Security misconfiguration. Security misconfiguration is one of the most common and easily exploitable vulnerabilities. It covers a wide range of issues where security settings are incorrectly defined, left at insecure defaults, or simply missing. Examples include a cloud storage bucket left publicly accessible, exposing sensitive files to anyone on the internet, a web server that still has the default administrator credentials, such as admin/admin, that were never changed after installation, an application that returns detailed stack traces and error messages to the end user, revealing internal file paths, library versions, and database structure to a potential attacker, unnecessary features or services left enabled, such as an open administration interface on a production server. In a DevSecOps pipeline, automated configuration scanning tools, sometimes called infrastructure as code security scanners, can catch many of these issues before deployment. 6. Vulnerable and outdated components. Modern applications are built on layers of third-party libraries, frameworks, and dependencies. When any of these components contains a known vulnerability and is not updated, the entire application is at risk. Concrete example: the Apache Log4 shell vulnerability discovered in late 2021 affected the widely used Log4j logging library for Java. Organizations that had not patched or monitored their dependencies were exposed to remote code execution attacks, meaning attackers could run arbitrary commands on the server without any authentication. This category highlights the importance of software composition analysis tools in a DevSecOps pipeline. These tools automatically scan your project's dependencies and flag known vulnerabilities based on public databases. Key practices to mitigate this risk include maintaining an inventory of all components and their versions, subscribing to security advisories, and automating dependency updates. 7. Identification and authentication failures. Previously called broken authentication, this category covers weaknesses in the mechanisms used to verify who a user is and how their session is managed. Common examples: an application that allows weak passwords such as 123,456 or password without enforcing any complexity rules. A login system that does not implement any protection against brute force attacks, allowing an attacker to try millions of username and password combinations automatically. Session tokens that do not expire after logout, meaning a stolen token remains usable indefinitely. An application that exposes session identifiers in URLs, which get logged in server logs or leaked through browser history. Multi-factor authentication, strong session management, and account lockout policies are the primary defenses against this category of risk. 8. Software and data integrity failures. Also new in the 2021 edition, this category covers situations where an application makes assumptions about the integrity of software updates, data, or pipelines without actually verifying them. Concrete example: a continuous integration pipeline that automatically downloads and executes build scripts from an external source without checking their cryptographic signature. If that external source is compromised, malicious code is introduced directly into the build process, a scenario known as a supply chain attack. The SolarWinds attack in 2020 is a real-world example of this type of compromise at scale. Another example: insecure deserialization, where an application accepts and processes serialized objects from untrusted sources. If the application deserializes malicious data without validation, it can lead to remote code execution. In a DevSecOps context, this is why pipeline integrity, signed commits, and verified artifact checksums matter, concepts you have already started to explore with Git. 9. Security logging and monitoring failures. This category is often overlooked because it does not directly enable an attack, but its absence makes every other vulnerability far more dangerous. Without adequate logging and monitoring, attacks go undetected, and when they are eventually discovered, the lack of evidence makes it impossible to understand what happened, when, and how. Examples of failures in this category: an application that does not log failed login attempts, making it impossible to detect a brute force attack in progress. Logs that exist but are never reviewed or sent to a centralized monitoring system. Log entries that do not contain enough context, such as user identifiers, timestamps, or IP addresses, to reconstruct the sequence of events during an incident. Alerts that are triggered but never acted upon due to alert fatigue from poorly tuned detection rules. In practice, security logging and monitoring is the foundation of incident response. As a DevSecOps specialist, you will be expected to integrate logging requirements into applications and pipelines from the start. 10. Server-side request forgery. Server-side request forgery, often abbreviated as SSRF, is a vulnerability where an attacker can cause the server to make HTTP requests to an arbitrary destination, typically an internal resource that should not be accessible from the outside. Concrete example: a web application offers a feature that fetches the content of a URL provided by the user, for example, To generate a preview of a link, an attacker provides the URL http://169.254.169.254/latest/metadata/, which is the internal metadata endpoint used by cloud providers such as Amazon Web Services. The server makes the request on behalf of the attacker and returns sensitive configuration data, including temporary access credentials to the cloud account. Server-side request forgery was elevated to the top 10 for the first time in the 2021 edition, reflecting its growing relevance as more applications are deployed in cloud environments with rich internal APIs. Why the OWASP Top 10 matters in your DevSecOps practice. Each of these 10 categories maps directly to specific actions you will take as a DevSecOps specialist. During a penetration test, the OWASP Top 10 gives you a structured checklist of attack vectors to verify on any web application. When reviewing code or configuring automated security scans in a pipeline, it tells you which types of issues to prioritize. When writing a vulnerability report, it provides a shared vocabulary that developers, architects, and managers all recognize. When designing security tests, both static analysis and dynamic analysis, the top 10 categories define the minimum scope of coverage. The list is not a guarantee that an application is secure if all 10 categories are addressed. Security is always broader than any single list, but it is the most widely adopted baseline in the industry, and mastering it is a prerequisite for everything that follows in this course. You should now be able to name each of the 10 categories, describe what they mean, give at least one concrete example for each, and understand why they are relevant to the DevSecOps pipeline you are learning to build.